So, we're going to be reviewing for our test tomorrow.
Thank you. Oh, oops.
Sequences. Our test tomorrow on sequences. So let's start with number 1. Number 1 says, select the expression that can be used to describe the number of squares in the following pattern. So what I'm going to do is I'm going to create a table. You ready? So they're off to the side. I want everyone to make a table for me. My pen. So I'm going to have n. That's the step, right? How many steps do I have? 4. 1, 2, 3, 4. And then I have a of n. And what are we counting? It says what we're counting. What are we counting? Number of squares. So how many squares are in the first step?
1.
How many squares are in the second step?
3.
And the third?
Instead of putting like an A with the N,
Sub of n, yeah?
Sub of N, can I just put number of squares?
That's up to you. I would prefer you use the function notation. So in the third step? 5. In the fourth step? 7.
Do they have to be lowercase n's?
Yes.
Oh.
Because look at your answer choices, Xavier. What kind of n's are used? All lowercase. That's why. All right, so what we're going to do, like we were talking about yesterday, I want to compare my table to these answer choices and see which one matches. You ready? So A. I have 1 plus n minus 1 times 2. So we're going to replace that 1 plus n. Now instead of n, I'm going to say 1 minus 1 times 2. What do I get? What's 1 minus 1? 0. 0 times 2? 0. 0 plus 1?
1.
1. That matches, yes? So let's try again. 1 plus 2 minus 1 times 2. So 2 minus 1 is 1. 1 times 2 is 2. 2 plus 1 is 3. Does that match? It sure does. All right, let's try the next one. 1 plus 3 minus 1 times 2. 3 minus 1 is 2. 2 times 2 is 4. 4 plus 1 is 5. Again, it matches. This one's looking pretty good, isn't it? All right, let's do one more. 1 plus 4 minus 1 times 2. So what's 4 minus 1? 3. 3 times 2 is 6. 6 plus 1 is... Do those all match? Yes, they do. So my answer is A. All right. Number 2.
I already started.
You did?
Number 2. Number 2. To select the expression that could be used to describe the number, the following pattern. I think it means the size of the square in the following pattern. There we go. Sorry about that. So let's plug in. I've got n and a of n. So my first shaded square is how big? 1/2. My second shaded square is how big? 1/4. My third shaded square is how big? 1/8. There's only 3. There's more, but we're going to stop at 3. That's a good place to stop. So let's compare to those answer choices and see which one is the best match. You ready? So, answer choice A. So in A, I've got 2 to the 1 minus 1 power. Well, what is 1 minus 1? 0. What's 2 to the 0 power? Not 0. 1. Does that match? No, so it can't be A. B. 1/2 to the 1 minus 1 power. 1 minus 1 is 0. What's 1/2 to the 0 power? 1, not 1/2. To the 0 power is 1. So does that match?
No.
Again, no. So let's try C. 1/2 times 1/2 to the 1 minus 1 power. 1 minus 1 is 0. 1/2 to the 0 power is 1. 1 times 1/2 is 1/2. That matches, doesn't it? All right, let's try another one. 1/2 times 1/2 to the 2 minus 1 power. So what's 2 minus 1? 1. So what's 1/2 to the 1 power? 1/2, right? So then what's 1/2 times 1/2? 1/4. Does that match?
Are you gonna have a calculator for us?
Yes, tomorrow you will have a calculator. All right, last one. Let's see if this last one works. So I have 1/2 times 1/2 to the 3 minus 1 power. So that's the second power? Yeah, we're still on C. We're doing the last one. Sorry, we're still on C. So 3 minus 1 is 2. 1/2 squared is 1/4. Remember the last problem? 1/2 times 1/2 was a fourth. So what's 1/4 times 1/2? 4 times 2 is 8. That's 1/8. Does that match?
Yeah.
Do we have a winner?
Yep.
Yep, we do. Winner, winner, chicken dinner. I love it. All right, number 3. Number 3 says, the following sequence is either arithmetic, geometric, or neither. If it's arithmetic or geometric, determine the next 3 terms in the sequence by calculating the common difference or common ratio. You ready? All right. So let's see if there's a common difference first. So from 75 to 100, that increases, what do we add?
25.
Bless you. From 100 to 150, we add 50. So do we have a common difference? No, those would have to be the same number to have a common difference. All right, so let's see if they have a common ratio. All right, so to find the common ratio, what we can do is we can divide. So I'm going to divide 100 divided by 75. Does that reduce? To what? See, 25 goes into 100 how many times? 4. 25 goes into 75 how many times? 3. So that's multiplying by 4/3. All right, what about 100 to 150? So we're going to divide again. 150 over 100. Well, what goes into 100 and 150? 5? What about 50? 50 goes into 150 how many times?
Twice.
50, 100, 150.
Oh.
3 times, right? 50 goes into what? 100 how many times? 2. So that's 3 halves. Are those the same ratio? No. So is this geometric? No. So it's neither arithmetic nor geometric. Is that okay?
Wait, is arithmetic when we add?
Arithmetic means you add or subtract. Geometric means you multiply or divide. Very good. Number 4. Number 4 says, tell whether the sequence is arithmetic, justify your answer. So if it's arithmetic, what do we know? We're going to add or subtract the same amount each time. Yes, exactly. So let's see. From 15 to 11, what happens?
Minus 4.
-4. From 11 to 7,
Minus 6.
-4. 7 to 3,
Minus 4.
3 to -1, -4. So is this arithmetic?
Yeah.
Yes. So let's mark out the no answers. So A says yes, the sequence is arithmetic because it has a common ratio. Can we have a common ratio if it's arithmetic? No. So then let's read C. C says yes, the sequence is, that should say is arithmetic.
Mine says of 3.
I know.
Oh.
There's typos all over the place, sorry. Is arithmetic because it has a common difference of, it should say -4. Sorry about that. I should have checked more carefully. I made mistakes, it's okay. So the answer would be C if we made those 2 changes. Right, Xavier? Are y'all ready for number 5? Okay. Number 5 says, find the common ratio of the geometric sequence. So to find a common ratio, do y'all remember from our notes on Monday, Miss Robin? Yeah? What'd you get? I can't see that far. What'd you get? Oh, you didn't get it yet? Okay. So, but do you remember from Monday what we said about a common ratio? We could divide the second term by the first term, and that gives us the common ratio, right?
It's times 3 is 3.
Shut up.
So 27 divided by 9 is 3, or you could look to see it's increasing 3 times each time, right? Is that an answer? It sure is. What about number 6?
Wait, is there going to be one like that on the test?
Mm-hmm.
Okay.
Number 6. Again, find the common ratio. So what are we going to do?
The first and the second.
The first and the second, so 2 divided by -6.
-3.
Is that right? 2 divided by -6? No, what's got to go on top? -6. Divided by 2 is -3.
Dang.
Number 7. Seven says, during Pedro's first week at college, his parents deposit $2,000 into a bank account for him. At the beginning of his second week, and at the beginning of each week thereafter, he withdraws $65 for meals. So we're going to write an explicit formula that represents the amount of money he has in his account for the nth week of college. I'm not going to worry about this last question. Let's just focus on writing the equation for this problem. Well, let's make a table. So the first week he has how much money?
$2,000.
$2,000. The second week,
$1,935.
how do you know he has $1,935?
Because he withdrawn 65.
So he took out $65. Beautiful. The third week, how much money will he have? 870? Right?
Yeah.
Okay, making sure. So now let's use this table and check it against these answer choices. You ready? Oh, I did not want to write. I was trying to move. So, answer choice A says 2,000 times 65 to the 1 minus 1 power. So what's 1 minus 1? 0. 65 to the 0 power is 1. 1 times 2,000 is 2,000, so that first one works, yes? Let's try the second one. 2,000 times 65 to the 2 minus 1 power. Oh, sorry, my pen keeps skipping. There we go. So what's 2 minus 1? 1. So 65 to the 1 power is 65. 2,000 times 65, Jaden. What's that? Well, think about it. 65 times 2,000. Is that going to be 1,935? So if I multiply 65 times 2,000, is my number going to get bigger or smaller?
Bigger.
Bigger, a lot bigger, right? So can A be my answer? No, let's mark it out. Let's take a look at B. B says there we go. Sorry, I couldn't see my equation. 65 plus n minus 1 times 2,000. So that n, I'm going to replace with 1. 1 minus 1 is 0. 0 times 2,000 is 0. 0 plus 65 is not 2,000, right? So it can't be B. So let's try C. We have 2,000 plus 1 minus 1 times 65. One minus 1 is 0. 0 times 65 is 0. 0 plus 2,000 is... All right, so far so good. Let's do the next one. 2,000 plus 2 minus 1 times 65. 2 minus 1 is 1. 1 times 65 is 65 plus 2,000. Does that match? No, so it can't be C. It's got to be D, but let's check. All right, I need a new color here. There we go. Let's go with pink. So D, I've got 2,000 plus n minus 1 times negative 65. Well, let's think about it. Is that going to work out better?
Yeah.
Yeah, because it's decreasing by how much each time?
65.
65, and that's what's happening in the problem, right? There we go. So that's got to be our answer. D. All right, number 8. Zoom in a bit here. Number 8's like our warm-up from today. 8 says, determine the first 5 terms of a sub n equals 1/2 times 2 to the n minus 1 power. We're also going to find a sub 8. So just to keep organized, I think it's going to be best to make a table here. Let's make a table. We're going to have n and a sub n. Now I want the first 5 terms, right, Ryan? And then the 8th term. So, 1. 1 minus 1 is 0. 2 to the 0 power is 1. 1 times 1/2, it's 1/2. 2. 2 minus 1 is 1. 2 to the first power is 2. 2 times 1/2, it's 1. 3. 3 minus 1 is 2. 2 squared? 4. What's half of 4? 2. So what's happening? It's multiplying by 2. It's doubling. Hi.
This prisoner?
Yes.
Just give it to her.
Thank you. So what's double 2? 4. What's double 4? Double 8. Right? So to get to 8, though, we've got to plug that in. So we're going to plug in 8. We could. So double 8 is 16, so that's 6. Double 16 is 32, that's 7. Double 37 is, that's 8. We could follow the pattern. You're exactly right. You ready for the number 9? Number 9. So again, the first 5 terms. And then I want to find a sub 13 also, right? So first, 1. 1 times 2 is 2. 2 plus 7 is 9. There we go. Next, 2. 2 times 2 is 4. 4 plus 7 is 11. 3. 3 times 2 is 6. 6 plus 7 is 13, right? Well, what's happening here? It's adding 2. So what's the next one going to be? 15. And then? 17. Well, this one's 13, right? So we're going to plug in 13. 13 times 2 is 26. 26 plus 7 is 33. Last problem, number 10. 10 says, write the equation that could be used to describe the number of matches in the following pattern. So in the first picture, how many matches do we have? 7. In the second picture, how many matches do I have? 12. In the third picture, how many matches do we have? 17. So, we have to write this equation. How many matches do I begin with? 7. So I'm going to say 7 plus something times, and then how much are they increasing by? 5. So my slope, my rate of change is 5, right? So we have to decide, are we going to multiply this by n or something else? Something else, because if I did n, 1 times 5 is 5. 5 plus 7 is not 7, right? So I need this piece to be 0 on the first try. So instead of n, it's going to be n minus 1, right? So let's check it. If I put in 2, what's 2 minus 1? 1. 1 times 5 is 5. 5 plus 7 is 12. It works, yes? Tomorrow, this problem will be multiple choice. You won't have to write it from thin air. It will be multiple choice. All right, but let's use that for 10b. It says use the expression from the pattern to find the 10th term. So what I'm going to do, I'm going to replace n with what? 10. So 10 minus 1 times 5. So what's 10 minus 1? 9. 9 times 5 is 45. 45 plus 7?
50.
That's it. Question? All right. Hang on to your review. I want you to keep it to study tonight. Yes, ma'am. As soon as Amy gets back. Listen, I've got lots of people who are missing things for me. I want you guys to use this time wisely. Use your time wisely to get work done.
I don't know about that.
Yesterday? Yes, and I graded it. I graded that one after I printed it.
What? Is this? Hey, just actually want to go in it?
Missing this one?
Is this Tommy?
I'm scared to get rejected.
These two?
He's wearing off-brand.
And this one. Find those three. We're going in next. Yes, ma'am. Are you missing anything? Study for your test tomorrow. If you're not working on anything, I'm going to remember that when I grade all your late work next Tuesday when you turn it in at the last minute.
When's the end of the 6 weeks?
Oh my God, I got this.
You need to sign these policies. Even the ones we did yesterday and Monday.
Look at my grade.
Huh? What? Yes.
You're complaining about your grades, but I'm like, I have a good lifestyle.
Square. No, thank you. quadratic. Writing equations of exponentials.
Oh my goodness.
Miss Jules? Jules? Xavier, do you have yesterday's assignment?
What do you mean?
Oh, you turned it in. Never mind. Xavier?